Good morning, students. So here in this part we are mainly discussing a few graphs of real functions. So see, I have written already a list of graphs. So these are most common graphs which we get in the books only. So there could be many graphs, and the graph chapter is very important. If you know it well, you can use its concept throughout the course in many topics also. So these are the very few graph types which I have specified over here. So we are going to discuss this and their domain and also range. So apart from this, I will advise you that you always try to learn other kinds of graphs available from other, maybe the JEE books, JEE main books, or maybe some higher mathematics books, so that those are always appreciated. So let us start with the identity function, the first one. So identity function. So identity function is actually number one. Okay, so it is actually y equals to x. Y equals to x is the identity function. So now if you draw the graph, so this is x and y axis Cartesian coordinate. So you will get a graph like this. You will get a graph like this. So this is the line of y equals to x. So you know that y equals to x means x and y are having same value. So it will be a line which will be at 45 degree with x axis. Okay, exactly midway. That means if x is 1, y is also 1. If x is 5, y is also 5. Even if x is minus 10, y is also minus 10. That means x and y are having same value. So basically, so this is y equals to x. Now we have to find the domain and range of it. So the domain of this is, you can see, it covers up all real values, even the negative decimals, positive decimals, and anything. So it's R actually. That means all real values x can take, and y is same. So range of f will also be R. Okay, range of f will also be R. So this is all with the identity function. Now let us see number 2, the constant function. So the constant function is something like y equals to k, where k is a constant. Y equals to k, where k is a constant. That means here what happens, if you draw, y has a fixed value. If it is positive, say y equals to 5, so it will be this line. It will be this line. So this point will be what? 0, 5 or 0, k I will write, better to understand. So it will be a line like this, x, y, and this is origin. So it will be a line which is parallel to the x axis. Okay. Now the question is, what will be its range and what will be its domain? As you can see, that the range will be R. Why so? Because it extends for its actually range will be its domain will be R, because x can have any value, right? X can have any value. So what happens over here? So when you extend this, you can put for x value as 5, x value as 6, as well as minus 10, minus 11, minus any decimal numbers. So basically when you write df, it will be capital R, all real values. Why so? Look at the graph. It's going to the positive direction, it's going to the negative direction as well. So taking all the positive possible values and also taking all the possible negative values. So x, that means the domain of this will be, domain of this function will be capital R, all real values. Now for range, do you think it's all real values for y also? Do you think that the graph also takes up all real values for y also? The answer is no, it does not take, because see, y is neither increasing nor decreasing. It's everywhere, it's fixed. And what is the value? The value is k. So it's only a fixed value. But k is a fixed value, so you have to write it. This is very important. You have to write it within as an element of a set. That means if you write like this k, then it's wrong, because k does not indicate any kind of set. K is a specific value of a set. So it will be like this. That means the range will be the value k, the real value k. So now we will see the next, that is the modulus function. So we study the modulus function now. So modulus function looks like this: y equals to mod of x. Now this mod is what? Mod turns any value to its positive value. That means if you write some kind of mod of -5, this will give you 5. And if you write mod of 5, this will also give you 5. So mod is an operator by which all the negative or positive values can be converted to its positive values. So the graph looks like this. So first of all, decide on one point, that y is actually positive, because it is always becoming positive. Whatever be x, whether it is positive or negative, y is always getting positive. So the range of this will be some positive thing. However, x, that means the domain can be anything. So if you draw this, it will be a kind of V kind of graph. So these are the coordinate axis, x, y, and the origin. And the graph becomes some kind of V touching the origin and going to a different direction. So you can see from the graph, the domain can be understood. That means the domain x, see, x increases indefinitely, x decreases indefinitely. That means a domain is always R, whereas the range is fixed. That means range is not fixed, range is positive. Range is positive. That means it's not coming down, it's going up. So it's, you can say R plus, or better to write something like 0 to infinity. That means it's a positive. Now here we see what we have done. We have used the interval concept of closed open interval. That means from 0 it increases up. So that will be the range of this. Okay, after this we learn, okay, one more thing to discuss over here. Mod x, if you want to express mod x, you can express it in this way. Mod x is equal to x when x is greater than or equal to 0. Mod x equals to minus x when x is lesser than 0. Now this seems very confusing. This, I have found that this is very confusing for the students. Okay, they think that why mod x becomes minus x, when I have already told you that mod x is always a positive quantity, it turns everything to positive. So why mod x is becoming minus x? The answer to this is, please listen to this again and again. When x is already negative, why negative? Look at this, x lesser than 0. When x is already negative, this minus is actually helping the negative x to become positive. This minus is actually helping the negative x to get positive. So that means when x is negative, this minus, with the help of this minus, it's getting positive, and that is what the mod function or the mod operator is doing. Okay, so that is this thing we will need throughout. So please remember this. After this, we start with the signum function. Signum function is kind of y equals to mod x by x. Now this mod x by x, it's defined in a very specific way. So there are values given for positive, negative, and also for 0. So what we do, we write here, if it is positive, so x, you know, x becomes positive, so mod x becomes x, like this we wrote. So x by x, it becomes 1. When it is 0, when x equals to 0, it's given as 0. It's given as 0. That means you cannot say that why it is 0. It's getting divided by 0. So it's 0 by 0, it's undefined. So all those questions, I think you cannot arise over here, since the function is defined like that only. The function is defined like that only. That means if x equals to 0, so it will be 0, and if x is lesser than 0, it becomes minus 1. Why it is minus 1? Then there also you will get a clue, because when x is lesser than 0, this mod x becomes what? Minus x. So minus x by x, it becomes minus 1. So there are 3 values, you see, minus 1, 0 and 1 for 3 different x values. So when we draw this, we see this is the origin. So where x is 0, the function, so this point is basically taken, and if this point is 0 comma 1, and if this point is 0 comma 1, and this point is say 0 comma minus 1, so it will be a line like this will be a line like this. That means, look at it, look at the small curve over here. That means this value is not taken. For x greater than 0, that means this side, for positive x part, the y value is 1. The y, this value is what? 1. And for x negative, that means for the negative direction, it's the y value is below, that means it's minus 1. So this is the graph, and this point is also taken. So x equals to 0, the function value is 0. So here what will be the domain? Domain means you can put anything, right? You can put 0, you can put greater than 0, you can put lesser than 0. That means basically you can put all values for x. So it's R. But when you get range, RF, range of the function, DF means domain of the function, RF means range for the function. So when you write RF, it means what? Only these 3 values. Look at this, either 0 or 1 or minus 1. So there will be a set, and specified to set there will be only 3 values written, that is minus 1, 0 and 1. So these are the specific 3 values, minus 1, 0 and 1. So that is related to this signum function. So next we will try to cover up greatest integer function. So now we start with number 5, which is greatest integer function, GIF. So greatest integer function also has other names like box function and floor function. Okay, so how it is written? It's written like this, y equals to box x, or you can also write some kind of floor function, that is floor x, like this. So, and what is the meaning of this? So let us first understand the meaning of this. Box x denotes it's always an integer, and it's the left hand side integer to be taken. That means if you get 2.3 box, the value will be 2. Okay, if you get 2.3 box, the value will be 2. Now people ask that what will be 2.9? So they think that it will be 3, but it's not. It's still it will be 2. It's the, if you take the number line, say 0, here there is 2.9. The left hand side integer is what? 2, and the right hand side integer is 3. So it's always the left hand side integer to be taken, which is 2. Okay. Now if you get only 2, box of 2, then what will happen? It will be 2. Okay. So box of 2 means 2.0, so that will be 2 also. Now the same thing if you look at, say, for minus 1.65. Now for minus 1.65, when you get this value minus 1.65, you have 2 integer in the ends. Here it is minus 2, here it is minus 1. So both sides you have got 2 integers. So what is the left hand side integer? That is minus 2. So it will be a minus 2 over here. Okay. So anything, say if you get minus 2.9, so it will be a minus 3 over here. So these are the basic idea of writing a box function or the greatest integer function. Now the graph is a step-like graph. You can see the book also. It will be better visible in the book also. So I'll try to draw. This is 1, 2, 3 and all. Okay, so from 0 to 1 what happens? So whenever you are getting some 0 to 1, say 0.3, okay, so value is still 0. So till 0.99, that means this point, the value is still 0. So this is the case. Now whenever it becomes 1, it jumps to 1 over here. That means the value starts from here. And again at 2, it creates a bubble. Whenever it is at 2, it jumps to 2. So it will be like this. Okay. So always you find that the right side of it has got a bubble because this value is not included. Okay. So whenever you see the negative side, so minus 1 and 0, so you like it's minus 1, then it will be like this, minus 2 to this, then this, minus 3 to this, it will be like this. So what we see over here basically is that y is always big. These are the x values, right? And these are the y values. So y values are always becoming what? Integer, and the x values can whatever be. Okay. Y values are always becoming some kind of integer. So when you write the domain becomes R. So you can put any real values for x and the range of this will become integer. That means you can write capital Z over here. So this is a kind of box function or a floor function where any real values to be put, and mainly I told you the secret that the left hand side integer you always consider. In that way it will be very correct. So in the next part we will cover up the smallest integer function and the other graphs whichever possible. Thank you.